So we've begun looking at industrialized materials that came online in the 18th century. And the first one we looked at was iron, which clearly has a huge impact on building structures. Today, I want to look at the sort of counterpart to iron, material that has more to do with building cladding, right? What we wrap or enclose buildings with. And that's glass, which, like iron, is not necessarily a new material in the 18th century, but it's one that is transformed by industrialization, as we'll see. Glass is this incredibly unique material. When you think about it, it's a material that is solid, impervious to air, impervious to water, but not impervious to light, which is sort of an incredible chemical coincidence. The chemistry itself is pretty simple. Glass is basically silicon dioxide, which is an abundant material. It's essentially sand, which can be found in the shores of rivers or beaches. But the key thing about silicon dioxide is not only that its molecular structure makes it basically pervious to light, so photons can get through, whereas in other molecules, photons tend to bounce off of electron clouds for reasons that have to do with atomic physics, and they're too complicated to get into here. But on a sort of mechanical level, glass is what's known as an amorphous solid. In other words, it's a molecule that wants to crystallize but isn't crystallized, and therefore when light hits it, it does not diffract or refract. It passes more or less straight through it. So this combination of the chemistry and the kind of mechanical qualities of it mean that you can have light that passes through unhindered, whereas in any other material it's either arrested at the atomic level or the mechanical level. So what essentially has to happen is you have to take vast quantities of crystallized silicon dioxide or river sand and melt it and cool it in such a way that it doesn't then reform those crystals. And this requires enormous temperatures to actually melt the sand, but also to very carefully control its cooling and its shape as it's cooling. And then once it has cooled, there have to be ways to finish or polish its surface, depending on what type of glass you want and how fine you want the material. As we all know, once you have made glass, that's only half the battle. You then have to transport it without breaking it, and its brittleness comes again from its chemical composition. But it is so useful, right? To have a solid material that is transparent is so useful to architects, builders, and users that over the course of human history, especially Western history, glass has been used despite all of these difficulties in manufacture and transport. Only in the last century has it become a material that is affordable for large-scale building use. Glass is mostly a material of the Western world. Its discovery occurred in the Eastern Mediterranean back around the time we were looking at the earliest Egyptian constructions. And it spread by 1500 BC or so to both Egypt and to Venice, which became, just on the basis of its being able to import both fuel and sand, one of the leading glass manufacturers and therefore one of the leading centers of glass innovation in the world. It's where we see glass blowing for the first time, where you put molten glass on the end of basically a long straw and use your breath, human breath, to inflate vessels on the end of the straw, what's called a punty. We don't see it very much in Roman architecture. We see plenty of glass being used in vessels or jars, bottles, things like that. There is some tantalizing circumstantial evidence that it was used in building, but it's never mentioned, for instance, by Vitruvius. So we know that it at least wasn't an often used material in the Republican Roman world, though it may have been in the imperial world, which would make sense. They would have had more funds and therefore been able to use more exotic materials. We know that it was used as decoration in the earliest of Constantinian churches. We know there were windows that used colored glass by 400 AD or so. And as Roman civilization, and particularly as Constantine's building program moved northward into Germany and eventually even into the British Isles, in those climates it's absolutely essential that you have a solid building wall, but it's certainly desirable that you would bring in light. And so this, we think, may have fueled the use of architectural glass in the northern realms of the empire. And the debate about whether the Romans used glass in their buildings or not is, I think, highlighted by the fact that we have abundant examples of glass in Roman sort of housewares. So jars, vases, candle holders, things like this, as you see on the left. We have only speculation about whether they were used in windows. And for instance, in the Roman baths, there are these so-called thermal windows that you see on the top. And there have been studies that show that, not surprisingly, the baths would have worked much better from a climatic standpoint if they had glass to keep the heat, for instance, in the colodarium or hot rooms. But we don't have a lot of archaeological evidence. We have mentions of windows and we have mentions of glass occasionally in text, but it's not widespread. And as I said, Vitruvius says nothing about glass. So we don't know, but we suspect that glass was not probably as widespread in the Roman world as one might think. By early medieval times, we have evidence in both text and in woodcuts, like you see here, for glass blowing as an industry. Certainly an artisanal industry, a very, very skilled process, and one that, of course, brought with it great danger to the glass blowers themselves. And the drawing on the left I like because if you go to a glass workshop today, you see essentially the same processes where the material is mixed, put into a furnace, stuck onto the end of a punty, or basically a long metal straw. And then, as you can see in both drawings, through a combination of inflating the glass bubble on the end of the punty, spinning it around on either a rough or smooth surface, as you see in the lower right, reheating it, reblowing it, reheating it, reblowing it, reshaping it, until you get the rough form that you want, and then cooling it either gradually or quenching it to temper it by putting it into a cold pot of water to sort of firm up the glass, to introduce thermal stresses that produce what we call tempered glass that breaks into small pieces instead of big shards. These were all things that were used even in medieval times to make mostly glass vessels, although also glass windows. And one of the things we talked about in Gothic architecture was the extensive use of colored glass in particular to create ornamental windows. And these go back as early as Saint Denis. You're looking at the upper register of Saint Denis here, so the later one. But even in the lower stories, I would think colored glass was used early on to create these narrative decorative windows. So windows that not only bring in light, but bring in light through ornamental panels that tell a story. You'll notice, though, that these are all, the secret to stained glass windows essentially is that they're composed of very, very small pieces of glass. So there isn't the capability to create the large sheets of glass that we think of as windows today. Instead, these are piecemeal and they're held together with lead or solder to form the framing and to form the outlines of the figures within the windows themselves. From Gothic times onward, Venice becomes the major center for the glass industry, which it still is in large part today. Two methods are developed for creating architectural glass as opposed to houseware or vessel glass. Spinning and cylinder, and we'll look at both of these here in a second. They're both related to the manual glass blowing that involves inflating them or using a punty to shape them. But as we'll see, they do this on larger and larger scales. And in the north of Europe in particular, glass begins to be used as what we might call a climatic membrane, a way to keep the cool air out, but to bring in the warmth of the sunlight, in addition to the ornamental purposes that it serves in Gothic architecture. And we see the migration of techniques coming usually from Venice, where things are kind of invented or perfected, and then either through artisans migrating or through trade, where people are seeing better and better materials coming out of Venice. By the middle of the 16th century, these advanced techniques exist in England as well as in the Mediterranean world as well. But it's still expensive. Glass becomes a way to sort of show your wealth. We'll look at a couple of examples of particularly ostentatious glass use in 16th century domestic architecture in England. And England realizes that glass is going to be critical to building not only houses, but also glass is going to be critical to its agricultural industries. And we start to see the development of so-called hothouses, what we would call greenhouses today. And the government gets very interested in sponsoring glass as an industrially produced material by the end of the 18th century. Steam power plays a big role in glass manufacture, not in the production of glass, as we'll see, but in the kind of finishing of glass, the polishing of the finished product. So as I said, there are two methods of glass production that are in wide use through the 18th and even the 19th century. And they both rely on a sort of variation of the standard glass blowing technique. One of them is called crown glass, and what this involves is taking a blob of molten glass, putting it on the end of a punty, but instead of inflating it, just spinning the punty, as you see the gentleman doing on the right, and letting the centrifugal force of the molten glass spread itself out into a thin disc, or a reasonably thin disc, maybe half an inch or so, that then can be gradually cooled and sliced up to create a type of window glass. You see on the far left two guys who are spinning some of the crown glass. You see various other stages. The guy in the back, very similar to the glass artisan on the right, single-handedly forming one of these large discs of crown glass. And here is what that looks like. You can see that because of the spinning process, you invariably get a region of glass that's quite distorted from where the glass met the punty to begin with. That can either be a flaw, as you see in the window glass on the right, or it can be a sort of feature. And you often see crown glass or imitation crown glass in sort of old-fashioned taverns or bars that are trying to look old-fashioned. The original idea was that you bring in light without allowing anyone to see like who's actually inside the bar drinking, right? So there's a level of privacy here. But crown glass is fairly inefficient in its use of material. It's thick. As you can see, it distorts the light even away from that kind of center spinning mark. And so while it's used extensively, it's not perfect. And there's a later development of what's called cylinder glass, which basically asks the glassblower to blow gigantic bottles off of the punty. So you can see there's a huge quantity of glass being put onto the end of the stick. That's then inflated, usually mechanically. The human lungs can't quite cope with this much pressure. And then, as you can see, those long kind of test tube shapes are sliced up. First, the ends are sliced off, and then the glass is remelted. The resulting cylinder, from which the process gets its name, is laid flat, and then that glass is carved up again into window panes. And what this does is it eliminates the circular mark or circular imperfection that occurs near the center of crown glass. So it's an improvement. It's a little more labor intensive. You see here a sort of 18th century French cylinder glass production. You can see the test tube shapes. You can see them cutting the ends off with shears and laying it flat on a table in the upper left. And on the right, you see the result, a slightly more consistent product, but one that you can see still has kind of waviness and distortion that's inherent in the cylinder process, right? None of the really remarkable distortion that you see in crown glass, but still a kind of waviness. It's certainly an imperfection. And these are the kind of artisanal glass methods that England relies on for some of its really great country houses of the 16th and 17th century. So when we think about these vast estates that the aristocracy and royalty builds in the era of the 16th and 17th century, we tend to think of these very large windows that bring in a lot of daylight during the winter. Of course, they are single layers, so they are also letting a lot of heat escape. But the trade-off, if that's all you have in the 16th century, is worth it. There's no other good way to bring in daylight or to illuminate the interiors. And so large windows are seen both as a kind of practical method of illuminating the interiors, but glass is still a very expensive luxury material. And these large windows become a sort of status symbol, right? A mark of the wealth that has gone into building these houses. Now, there's a third type of glass production that will become increasingly important as we see the material get industrialized, and that is plate glass. Plate glass is the most difficult of the three methods because it's not a kind of artisanal method. You can't just ask one or two glass blowers to manufacture glass this way. You have to actually have not just a workshop, but an entire factory. And the reason is that plate glass only works with sort of very large quantities. You take a huge amount of river sand, you put it into a furnace that is enormously hot. You take a bucket of the resulting molten sand or silicon dioxide out, and you pour that bucket onto a casting table. And these are two views of the glass being poured onto one of these tables. You can see on the right, the two gentlemen are using basically a large rolling pin to flatten that molten glass. And then after the glass cools, you have a very, very consistent plate of glass, usually about an inch or an inch and a half thick. The surfaces are rough, but the material in the middle is perfectly fine. And so you take that piece of glass to another workshop and you grind off the rough surface and then polish the resulting smooth surface. And this gives you a finish and a surface that's virtually perfect, right? You can get this as smooth as you want, and therefore you can get the glass almost as transparent as you want. This is at first an extraordinarily labor-intensive process to first make all of this glass and then to grind and polish off usually about a third to a half of the material. On the left, you see workers actually doing it by hand. On the right, you see a glass worker. What he's doing is called walking the plate. So the rough glass is put onto a bed of plaster of Paris that is attached to a large metal grinding wheel. And he is literally on his hands and knees pressing that rough plate into the bed of plaster of Paris so that it will stick when that wheel goes into the grinder and starts rotating, grinding that glass against a series of wheels that give it a finer and finer finish as it goes through the process. Now, plate glass is one of the material processes that does get industrialized. So the furnaces use at first wood, and then in the 18th century coal, and then eventually natural gas. So the plate glass industry at first migrates toward Pittsburgh, where there are a lot of petroleum reserves. You can see on the right that while it's still a labor-intensive process, by the 1890s, the casting process benefits from new machinery. So using iron to make the tables, to make the cranes that lift the buckets. And then on the lower woodcuts, you can see that the grinding and polishing methods get powered increasingly first by steam and then eventually by electricity. So you can, if you look at the kind of number of people in the scenarios that we just looked at, you can see that by 1895 there are fewer folks moving all of this hot stuff around. And by the turn of the century, you can see that the process is largely mechanized, if not automated. So you still have glass workers who are moving sheets of glass or plates of glass around, but increasingly both the furnaces, but also now the grinders and polishers are mechanized and attached to either steam power or eventually to electric power. And that brings the price of plate glass gradually down. It's a luxury item through much of the 19th century. It's only in the late 19th century that plate glass becomes competitive in price with cylinder or crown glass for building. But its qualities, its perfect surfaces and its transparency make it the material of choice for building enclosures in commercial and institutional functions throughout the 20th century. So in the next bit, we'll look at how this kind of wonder material gets put to use in a particular tradition that happens in Northern Europe, where again, they need to button up their buildings, they need to enclose them, but they want to bring in as much daylight as possible, particularly if you're trying to grow things in a climate like Britain's where the growing season is quite short.